Hello students. In yesterday's class we have started with the Fourier representation of periodic signals and its properties like linearity, time shift, frequency shift, scaling, time differentiation and convolution. Today let us see the Parseval's theorem. If x of t Fourier series representation with omega naught angular frequency of x of k, then 1 by t integration x of t mod of x of t whole square dt is equal to sigma minus infinity k equal to minus infinity plus infinity x of k whole square. We have to prove this one. Now the average power of a periodic signal, already we have done this one in the first unit where we have calculated the power and energy of the signals. The same formula we are using here. The average power of a periodic continuous time signal with x of t, so continuous signal x of t with fundamental period t is given by p is equal to 1 by t integration between the time limits x of t modulus whole square into d of t. But x of t we can write as x of t into x conjugate of x of t into dt. Now this x of f's conjugate of t, we are using the first formula of the chapter, that is nothing but this formula x of t is equal to sigma k equal to minus infinity plus infinity x of k e raised to j k omega t, where x of t here conjugate we are taking, therefore here also complex conjugate here. So 1 by t x of t. Now changing the order, so we'll take here first summation, will take here integration here. So summation 1 by t sigma k equal to minus infinity plus infinity x of k integration x of t e raised to minus j k omega t dt. But this expression whatever is there, this part is nothing but x of k as we have seen the formula. Then remaining part is x complex conjugate of k. So here if we see sigma k equal to minus infinity plus infinity x of k into x of k complex conjugate will get sigma k equal to minus infinity plus infinity x of k whole square. Therefore 1 by t integral x of t whole square dt is nothing but sigma k equal to minus infinity plus infinity x of k modulus whole square. Now let us solve some problems on this one. So this is a model paper question, 6 marks question. For this signal x of t is equal to sine omega naught t, find the Fourier series and draw its spectrum. So we have to draw the spectrum. This is the first problem we have to. So x of t is nothing but sine omega t, and where omega t is the frequency. So x of t I can write as e power j theta minus e power minus j theta by 2. Here in place of theta you have omega naught into t. Therefore 1 by 2j e raised to j omega naught t minus e raised to minus j omega naught t. So this will split to 1 by 2j, you multiply inside. So 1 by 2j e raised to j omega naught into t is minus 1 by 2j e raised to minus j omega naught t. Now according to the formula x of t is equal to sigma k equal to minus infinity plus infinity x of k e raised to j k omega naught t. So let us take this is equation 1, and this equation again I am writing here, where if you see here this equation, compare this equation. So x of t, here also x of t, here summation of the terms, here you have sum of the terms, here different terms. So here you have two terms, that is from minus infinity to infinity. Here you have two terms. Now we'll compare this x of k is nothing but this term, and e raised to j and omega naught t, here also you have omega naught t. In place of k you have 1. Here also if you see minus 1 by 2. So x of k is minus 1 by 2. E raised to minus j, here this term we are writing here minus omega naught t. Now comparing these equations, here k is what? 1. Whose coefficient x of k is nothing but 1 by 2j. Here k is minus 1 and whose coefficient is x of minus 1 is equal to minus 2j. So x of 1 and x of minus 1 is given, and x of k is equal to 0 for k not equal to plus or minus 1. Now, so we have found here the Fourier representation of the signal. Now we'll draw its spectrum, that is magnitude and angle. So here k versus magnitude of the signal. X of 1 is nothing but 1 by 2j, whose modulus is nothing but I'm multiplying and dividing by j. So here j square minus 2 by, so it is 1 by 2. Similarly, x of minus 1 is also 1 by 2. So angle, how do you find? Tan inverse of y by x. So if you see here, this one, for this part, this is imaginary part by real part. Imaginary part is 1 multiply and divide. So it is 1 by 2. And also here for this also it is 1 by 2. So here multiply and divide by j. So here have minus 1 by 2. Here plus 1 by 2. Now tan inverse of minus 1 by 2 is nothing but pi by 2. So for it is minus pi by 2 is minus pi by 2. Therefore, at 1 it is minus pi by 2. Now, similar tan inverse of minus it will become plus here. Plus 1 by 2 is nothing but plus pi by 2. At x of minus 1 it is plus 1 by 2. So, pi by 2 is the angle. So, in this way you have to draw the magnitude and also the spectrum. This is nothing but magnitude. This is spectrum of this one. So, this is called spectrum, magnitude and phase angle. Now let us do another problem. Evaluate the Fourier series representation for the signal x of t is equal to sine 2 pi t plus cos 3 pi t. So we have whatever the given equation is there, we'll write as a 1. Now if you see first signal, the frequency is omega naught 1, which is 2 pi, and second signal is 3 pi. So here both the signals, if we take the GCD of this one in order to find the common angular frequency, so GCD of omega 01 and omega 02, so if you find 2 pi and 3 pi, it is pi. So x of t is equal to, so we'll splitting this one using the formula. Sin theta is nothing but sin e raised to j theta minus e raised to minus j theta by 2j. So we are using this formula. For also cos, it is 1 by 2 pi e raised to I theta plus e raised to minus I theta or j theta. Here, so splitting here both the terms. Now writing this as here. Now j, you know the angular frequency omega naught is nothing but pi. Therefore it here pi e 1 by 2j is nothing but x of k e raised to j 2 pi t plus all these terms. So you have all these terms. Now compare this one equation with the standard equation, this equation. So here x of here 2, this in place of k you have 2, so this is nothing but coefficient of x of 2, which is nothing but 1 by 2j, and here x of minus 2, whose coefficient is minus 1 by 2j. Here for this term, here 1 by 2 e raised to 3 pi here. Now 1 by 2 here e raised to minus 3 pi here, and all these terms here coefficient is 1 by 2, here coefficient is also 1 by 2. Therefore only for this term the k equal to plus 2 and minus 2, 3 plus 3 and minus 3 you have non-zero values. For other values other than this one you have 0. Now we'll draw the spectrum of this one. Any problem asked like this, you have to find x of k Fourier representation and also the spectrum of this one signal. Now here if you see, the magnitude of this one is 1 by 2, even all these terms is 1 by 2. Therefore the magnitude at x equal to 2 is 1 by 2. So we'll draw this one, and x equal to 3 also it is 1 by 2, minus 2 it is 1 by 2, and minus 3 also it is 1 by 2. Now similarly, angle of this one, angle of x of 2, what is x of 2? X of 2 is nothing but 1 by 2j. So multiply and divide by j. So you will have here tan inverse minus 1 by 2, it is nothing but tan inverse minus pi by 2. Now similarly, multiply and divide by j here. So it is tan inverse minus of minus plus, therefore it is plus pi by 2. So here at x equal to angle is at x equal to 2, it is minus pi by 2. At plus x equal to minus 2, it is plus pi by 2. And x equal to 3, it is 0. This is at 2, sorry. So it is at x equal to minus 3 is also 0. This is the spectrum of the signal. So So let us do the another problem here, which is an important problem. It is a model question paper problem, and even last year this same question has been asked with the same values, everything same, it is being asked. So let us solve this problem. For the signal x of t, this is x of t given, shown below, find Fourier series representation and draw its magnitude and phase spectrum. Okay, here this is a signal whose x of t is nothing but e raised to minus t. So now from observation you can see after every time period 1, so the signal is repeating, therefore time period is t is equal to 1. Omega naught is equal to 2 pi by t, but t is how much? 1. So 2 pi by 1 is nothing but 2 pi, so omega naught is 2 pi. Here now we know the formula, x of k is equal to 1 by t, which is nothing but, here we have to take here 1 by t, which is nothing but 1 integration in the time period x of t e raised to minus j k omega naught into t dt. But what is omega naught? 2 pi. We can, in the next step we can substitute this value, therefore 1 by 1 integration t equal to 0 to 1 e raised to minus t, because x of t is nothing but e raised to minus t, e raised to minus j k 2 pi, here we will take 2 pi here, t into dt. So now from these two terms we can take out minus t common. So if you take minus t common in the in the power, therefore integration t equal to 0 to 1 e raised to minus 1 plus j 2 pi k into t. So apply the integration. This is of the form e raised to minus a theta, therefore it is e raised to minus a theta by minus a. Therefore you also substitute the upper limit and lower limit. So substituting the upper limit and lower limit, you will get something like this: 1 minus e raised to minus 1 by 1 plus j 2 pi k. So here 1 minus e raised to minus 1 is 0.63 by 1 plus j 2 pi k. So here how did you get this limit here? E raised to minus 1 2 pi j, this whatever the limit is there, substituting the upper limit and lower limit. If you substitute the lower limit, this entire term will become 0, e raised to minus 1, right, e raised to minus 0, therefore it will become 1. So here it is 1, lower limit is 1. Now upper limit, if you see here, e raised to 1. So here I am splitting this e raised to minus 1, and here e raised to minus j 2 pi k. So multiples of this one, k is integral value. So suppose if we take k is an integral, here k takes the integral values, therefore 2 pi, this is nothing but cos theta plus I sin theta, here theta is nothing but 2 pi, therefore it is cos 2 pi plus sin 2 pi. So multiples of sin is nothing but here 0, therefore cos pi, it is what? 1, right, therefore e raised to minus 1 into 1, therefore it is 1 minus 1, therefore here it is 1 minus e raised to minus 1, and this symbol here you have a negative sign here in the denominator, for that we have taken 1 minus this term. Now we have to sketch the magnitude plot. This is magnitude plot and this is phase. This is the phase plot. Now let us take the k, and also this is the magnitude plot. Now for in this problem, substitute k equal to 0. If you substitute k equal to 0, what happens? This imaginary part becomes 0. 0.632 divided by 1, it is 0.632. Therefore it is 0.632. Now substitute k equal to 1. If you substitute k equal to 1, what happens? If you substitute k equal to 1, it is 0.632 divided by 1 plus j into 2 pi into 1. Now we have to find, here in the same problem we'll solve. Here if you take the angle, it is 0 here, because it's a constant value. For the constant value it is 0, right. Now for the same, in the same, for this one we'll calculate angle, magnitude and also angle. For this one, when you are doing this one, you have to keep your calculator in radians mode. Keep the calculator in the radians mode. Just see here, first go to the complex mode, write this one, which is nothing but 0.0632 divided by 1 plus 2 into pi I. Remember, you have to do it in the complex mode. and also keep it in the radians here, equal to, now we want in the polar form, shift 2 3 equal to, so you'll get magnitude is 0.099, so we'll take round it off to 0.01, so amplitude is 0.01 and phase angle is minus 1.41. Similarly, you solve for all the values k equal to 1, 2, 3 and all, k equal to minus 1, minus 2. You'll get the phase magnitude and phase angle. Thank you.